sun flare that actually moved it away. Did you see that?
What's the black stripe?
Oh, that's the arm that holds that little disc so that the lens doesn't get burned. But you can see that that sun flare moved that that comet away from it.
This is the Vatican that did all
Well, the Vatican has a large investment in most of the probes that observe the sun and the dates when it was going to come back. Well, they missed by 2 weeks. And all the people that are looking for Planet X, they're all disappointed because they say Planet X didn't show up. They didn't notice a comet twice the size of Jupiter showed up. The comet was 2 weeks in advance from the Sumerian text, but hey, on a 10,000-year prediction, I think that's pretty dang good. Right?
It's a quarter-inch off.
Yeah, exactly.
Was it observable from?
It was. Yeah, it was observable from the west coast here very early in the morning, at sunrise, I believe.
What month?
February, yeah.
Of 2003?
Yeah, last winter. And here's the map when I updated it, and it showed the comets. And there was 2 comets that went by, one after the other. Now let me play this in slow-mo. This first comet came by, which is already enormous. And then this one. Check this out.
Are they in the same orbital plane?
No. They're on an angle coming in.
Right, so it's not quite as bad as it looks.
Yeah. However, the gravitational field of an object that big going inside the Mercury orbit should have pulled Mercury right into the sun. And look at the tail. When it's at the sun, the tail is still in the Earth's orbit.
Well, if you know where the orbit is, you should be able to calculate what
The gravitational influence was.
yeah, what the perturbation is to the orbit.
Yeah, we did. We shouldn't be here.
Why are we here? Why are we here?
If it didn't snap back, that means it still moved.
Pardon me?
The orbit of the Earth, you know, I mean, if you're saying that it changed the orbit of the Earth, then it's changed.
Oh, it didn't. Because if it did change the orbit of the Earth, it would have changed. The calculation showed that it would have changed it significantly, and a significant change in our orbit would have generated tidal waves and all sorts of events on the surface of the planet that we didn't see.
Well, not necessarily.
Well, mostly necessarily, yes.
A small change over time would be a big change. A small change in a short time.
It wouldn't be a small change. It would be a large change, including Mercury going into the sun behind the comet. You know? You're talking a huge gravitational field here. Extremely large. I believe that we were given another chance.
We're really not here. We just think we're
Well, I think we're floating in grace. We're definitely floating in grace at this point, and somebody is taking care of us. Go ahead.
And with a tail that large, I'm amazed that we didn't get more of a visual on that thing from Earth.
Well, it's because of the angle at which it came in, and the angle of the Earth relative to it. It was not easily available. But there's pictures on the net of it. People took pictures in the morning of the comet. It's enormous.
It occurred that quickly. It was pretty.
Yeah, it was moving extremely fast. It moved extremely fast. Within a question of a few days, it was out of our solar system. Yeah.
the size of a comet. I mean, the mass of the comet isn't based on the size of the comet. The comet is here extremely large, and yet be extremely small, but what we see is the expanded gap. Were they actually able to see the nucleus of the comet?
Yeah, the expand. Yeah, the expanded gas, that's a good point. The expanded gas of that comet is much larger than the sun.
Well,
Yes,
the
yes.
material size thrown it would tell whether or not it was really exact.
You see the size of the perturbation and the expansion of the gases around the comet makes the size of the comet actually much larger than twice the size of Jupiter. So when they say twice the size of Jupiter, they're talking about the nuclei of this comet, because the material around it, this is the size of the sun. The material around it makes it almost as large as the sun.
You're talking about size or mass?
I'm talking about size. The mass is directly related to its composition, which is supposed to be mostly ice and rocks. So,
It could be a concentration in any particular gas.
well, yeah, but that would be an unusual comet. In general, comets are ice and rocks.
Which would make its mass so close to the sun's mass. The sun is gaseous. The solid object that size would have a mass.
An extremely large mass. And the calculations show with a comet made out of ice and rock of this size, the gravitational field is extraordinary, is enormous. Go ahead.
So you're thinking that this was definitely a comet, this wasn't a starship.
Yeah, this was definitely a comet.
They were protected by other forces, but this wasn't, this was just a comet. That wasn't really.
That's right. Because you see on this one, you know, unlike the videos of these other objects, you can tell there's a pretty good tail there, you know. I mean, this is a tail the size of an astronomical unit, almost, from the sun to the Earth, you know. So that's, you know, that's appropriate for a comet, you see. Go ahead.
What's the source of this? Is this is an animation, obviously, since the Earth is in it, or is it?
Yeah.
Yeah.
Yeah, this is a program that gives you the activities that are going on in the solar system.
But it's based on measurements.
Yeah, it's all absolutely accurate to what's going on out there. At least some of the stuff that's released by NASA, in any case.
That's actual footage, right?
That's actual footage, yeah. This is not an animation. This is pictures taken by Soho of this comet going by. Go ahead.
With regards to the, what are your information and thoughts on what the latitude was with regards to the sun, where that came from, and might that affect?
Because that would have created a large perturbation in our daily life. Now, the sun is not, you know, the activity that's going on in our solar system is just outrageous right now. You guys need to know about this. It's kind of nuts. This is what the sun does every year. Every 11 years, I'm sorry. It's called the sun cycle. Every 11 years, the sun flips its poles. Its north pole becomes its south pole, and its south pole becomes its north pole. And when it does that, and I don't mean that it flips its physical poles, it flips its magnetic poles. And when it does that every 11 years, it goes from a smooth surface with not too many sunspots to more and more sunspots, till it reaches its peak and flips its pole, and then it goes back to normal. It goes back to this type of structure. So this was the approach to the last sun cycle, the last solar maximum. Go ahead.
Is the solar maximum concurrent with the minimum magnetic field? Just prior to swapping?
No, it's concurrent with the maximum magnetic field. The magnetic field becomes extremely active because of all of the sunspots generate a huge magnetic field and huge X-ray emission as well. Sunspots generate huge X-ray emissions, and that's because material is being sucked inside a black hole, and you expect X-ray emission from that. But as you look at the sun, you find that these sunspots, you know, are supposed to go to a maximum and then go back to normal. So here's the sun in 97. The sunspot maximum was